Hey fam, here's another music system video. Someone asked to see how you hook it up to gameplay, some sort of interactive music system. And I also thought it would be a good opportunity to show off some other stuff that MetaSounds supports, which is pretty cool. Which I think is, right now it's pretty limited, but like it's still very useful as it is right now. And then hopefully it will grow and expand later on. But basically, what I have here is a different music system. This is or sorry, different music queue. This was originally written for a very old live stream where I gave here's how you do interactive music without any cool features. It was just like blueprints, and you don't have time synth, you don't have chords, very bare bones, and so it is not necessarily edited the way that I would um, edit a queue now with all those features. I think that's really important. I think that's really important that when you're editing and you're designing and breaking up stems and all that sort of stuff, you need to have a very good idea about the implementation process, so that you can best take advantage of those features. So anyway, so the way that this system works is it's like your vertical slices. There's three main segment types. There's an intro. There's a main loop, which is 8 bars, and then there's a ending. And the vertical slices are additive. So you have a base, and then you have a mid activity level and an upper activity level. And I actually find 3 very naturalistic. I don't know if I've talked a lot about it, but if you ever want to learn about best practices for these sort of additive activity levels, I highly recommend, the Henry Mancini's orchestration book. There's I think it's called Sound and Score, or something like that. I have to look it up again. But that book is amazing. And there's a chapter where he talks about scoring for shows, and in his case, it's like how do you arrange your music for a live show, like a musical or like a variety show or whatever, where you have like a live band, but the problem is that you don't know how big the band is, and so he describes techniques where you basically are able to build up the arrangement from a very small ensemble to like a very large ensemble. And I find that technique is a really great way to create these extended activity levels without making it sound like it's too much of a fade. Because the fade is like the thing that it sounds artificial, and you don't hear it in a normal soundtrack. But so yeah. Anyway, uh, there is some of that here, but it's decently masked, I think. But anyway, that's me rambling about orchestration. I find it a really interesting topic. Anyway, so you have an intro, and then the way this was edited was actually originally it was supposed to be all these overlapping components, and then you do crossfades. So I've sort of tightened up the edits a little bit from the original live stream version. So like here you have an intro, and then you have the intro has like one beat of overlap into the main loop, and then the endings actually don't have the endings. The endings don't have any specific, runway. It's just the first bar and a half of each ending is very similar to what would be in the loop. So you have a lot of flexibility in terms of the fade time, but we can get away with one beat. So the way that this works is you have an intro, it goes to the main loop, the loop goes and goes and goes and goes, and then when you call it end, based on which part of the loop you're in, it will select one of these endings. And this ending, these two clips are good for either ending with the B segment or the D segment. And then these upper high activity levels are the only ones that you would change out. And then the other ones have completely different endings. And this just lines up. So ending A is like, if we want to end here, then we switch over to ending A. If we want to end here, we switch over to ending B, here, C, etc. And so the thing that I want you, that's the cool part, is this support for cue points. So in UE5, sound waves can store cue points. And this is very useful because there's a lot of folks out there who like to write their interactive music branching using cue points instead of segmenting up the music. And so so what we have here is a cue point to indicate when we want to do the crossfade out of the intro and into the main loop. And then we have a bunch of cue points for possible endings. And the thing that you want to care up this, so this is the important part. The name is only useful for debugging right now. The ID number is what you really care about. This is the important thing, because that's the value that we're going to use in our music system. Yeah, so that's, and then the other thing that, if you're in Reaper, when you render, make sure down here that you have selected to export markers. I only wanted markers only. I didn't want any of the loop regions. I don't think that there's support yet for regions, but they might show up as additional markers, so I didn't want to mess around with that. So I just put markers only. So that's the other thing to make sure you're aware of. So here's all my renders, and then let me just play it, and I can just describe basically how it works, how I've got it set up, and then we can go through it. So when I start playing, it will play the intro. And like I said, there's three activity levels. There's a base activity level if you're not moving. And then if you start to move, it will gradually climb up to the mid activity level. And then if you keep moving, it'll go up to the upper activity level. And if we listen to, say, the main loop here, the base activity level is quite chill. It's very ambient. And then the mid activity level adds some like agitation and some, life vibrations. And you've got the woodwinds giving a little bit of a rhythm. And then on the upper one, you have the strings, the high strings, going to join the woodwinds. And then you have like brass coming in. So what I have it hooked up to is the pawn velocity. So when the pawn starts moving around, it will start gradually climbing up. And then when I stop moving, it will gradually climb back down. And then I have a trigger box for when I go inside this trigger box, it will cue the ending. And the ending is not like snappy. It's like a very gradual ending. All right. So then if I stop moving, it will slowly chill out. And that sort of that melodic callback, or that melodic callback, that I go between a flute and a trumpet because the timbre actually is very good at masking the trumpet fading out of the flute, the timbre of the flute, which I find really interesting. And then we'll jump. Oop! Oh, I didn't make it. I'll jump from one of these. Ah, there we go. And then we'll transition to the ending. And unfortunately, I can't move around up here, so you don't get to hear the high activity ending. It's cheesy, but it was for a demo, right? Okay. So let's take a look at how this music cue works. Let me switch this view to small tiles. Okay, so this is the cue. And like I said, it's basically 3 segments, right? So we have an intro segment, and I'll go into what this is. This is part of this is one of the other features that's really cool, is we call composition. But basically, you can put MetaSound inside of another MetaSound, and you can make custom MetaSound nodes, which aren't just source MetaSounds, but just custom nodes with arbitrary inputs, arbitrary outputs, which I'll show in a little second here. So on play, we start playing this. See, this is called 3-layer crossfader, because it's 3 layers, right? So we have segments that are all supposed to line up in 3 layers. On play, it's not looping, and then we have our 3 layers, our base, mid, and upper layer, and then we have an intensity value that we pass in. And then on the cue point, remember that one cue point that was authored on the intro, we trigger a timed crossfade at the same time as we trigger playing the main loop, and the main loop is actually looping. And then we have our base, mid, and upper, and the intensity control right there. And those are all just going to the mixer here. And so this little crossfader is just multiplying, is just affecting the gain of the intro gain, and then is multiplying things that affect the main loop gain control. And then what we have is a trigger input on end, which we only want to trigger once because it's ending the piece for us. And this goes to, I could just do this. This opens up a trigger once. So this trigger once started closed. So basically the idea is the cue points, because it was like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 in our main loop. The cue points keep trying to trigger the ending, and this is closed to the cue points. So basically, the on end, what it does is it doesn't trigger the ending directly. What it does is it actually triggers the gate to open. The trigger wants to reset, and it allows the next cue point to trigger the ending. And then what we have is the cue point ID is actually being used to address an index on our array. So we have an array of base endings, mid endings, and upper endings. And basically, if its ID is 1, then the index we want is 0, which is base with the A trigger, and then it's B, and then it's C, and then it's D. And then it just passes that in to another 3-layer crossfader MetaSound, and at the same time triggers our timed crossfade, which is 1 beat long. And we're still passing intensity value in. And then when this is done, it finishes the piece. Now, if we let's look at the 3-layer crossfader. We can just double click and it'll open it up. And it is comprised of 3 wave players, as we would expect, with inputs, bass, mid, and upper wave inputs, the on-play input, and then the looping input. And then we just take the upper one as the, we are making assumptions that these are all synchronous to each other. And then we have the intensity value going to a map range. So you'll see that the bass is always at 100% volume, so we always hear the bass music. And then then we have the intensity coming in as a 0 to 1 value from gameplay, being translated to a 0 to 2 value. I could have just done multiply by 2. That would have been fine too. But the map is always very clean, and it's very, what I like is that it clamps it. And then we have one of these values going to a clamp, which is just 0 to 1. So that means when this is going 0, it's going up to 2. About halfway, this gets filled up. This clamp gets filled up. And that is going to our gain, the mid-level gain. And then the upper-level gain, when this is going up 0 to 1, and then 1 to 2, on its way to 0 to 1, this value is -1, which means it's -1 to 0, which means it's below the clamp. So this stays at 0. And then when this goes 1 to 2, it's -1, so then it's 0 to 1, and then it's actually filling up 0 to 1. And that's how you get the mid-level filling up before the upper level fills up. And this, I've tried 2 tiers, like splitting the mid into lower and upper and just having 2, and I don't think it's as good as having 3. I think 3 is the best. Obviously 4 could be even more compelling, but I think at that stage, I'm not sure what you're getting out of it. You might even want to add something, some sort of stinger or something like that, because you're really active or something. I don't know. Or you switch to another cue or something. The music, I feel, has to change if it goes too much. Anyway, that's the 3-layer crossfader, and we're just reusing this. So this is just stored as stored as a MetaSound that's just chilling and available to us all the time. And then the other custom MetaSound we made was this timed crossfade. And it's very simple. This is not a MetaSound source. So when you see add sounds, MetaSound, this will probably rename to MetaSound Node. There's just a lot of debate about what to call this, because its usefulness is very broad. But basically, the idea is you can create your own custom MetaSound nodes that have arbitrary inputs, arbitrary outputs. So this is a custom MetaSound node. It's not a source, so you can't play it in the game, but you can use it in your MetaSounds. And it has a trigger input and a time input. And then it has basically all I'm using is the attack segment of this envelope. So you trigger it, you give it the attack time, and then it spits out a 0 to 1 value that climbs from 0 to 1 over time. And then the output A is a float that defaults at 1, and output B is a float that defaults at 0. And then as the envelope goes up, 1 minus the value of the envelope will end up going from 1 minus 0 to 1 minus 1, which will be 0. And so this value will go from 1 to 0. And this value will go from 0 to 1. Make sense? There's some other, I could have also added the attack curve as a possible input if I wanted to control that, but I was keeping it simple. And then I could also have the decay triggered output as like the attack is done. But like I said, I kept it simple, and then all I did is I fed in a BPM to seconds converter, which took 65 BPM, which is the BPM of the piece, and a quarter note division, and I just passed that in as seconds. And the same thing down here, it's identical. So so each transition just is sort of smoothed out by a little crossfade of 1 beat. So that's how the system works, and I can play it right in here, and it works. I can test it out. Here's the intensity control. This is where you want to like simulate maybe what the behavior would be like in the game. And then when you want to simulate the on end, just simulate that right now. You'll see it'll trigger the on finish when it's done. Boom, and the song is done. Or sorry, the piece is done. So let's take a look at the gameplay blueprints. It's very simple. Okay, so here on begin, I spawn the sound that plays my music cue, and I cache it as an audio component. And then on the tick, what I do is I use an finterp2 with a pretty slow speed. And I am just basically the target is being controlled by the player pawn. So assuming there's a valid player pawn, I am the target is set to whatever the player pawn is doing. So if the player pawn as it moves around is basically going at 500 units, and so I just convert that to 1. The player pawn isn't actually very interesting. Like it just like suddenly starts moving at a constant rate. But we can make it gradual with this finterp. And so when the target is 1, then and let's say the current value is 0, then it'll start interpolating up. And then when the target drops back down, it will switch course and start interpolating down. So this is a very good way to kind of smooth out your continuous data. And then I just check that the audio component's valid and that it's playing. And assuming all those things are happening, then I am passing the intensity value in. And then on the trigger overlap, and the only thing that I did with this trigger is you'll see in the details what I've done is I've customized the collision preset to only overlap on the pawn. So no other geometry or world stuff or even the camera can trigger this overlap. So when the overlap is triggered, assuming that the audio component is valid and it is playing, then I pass a execute trigger parameter on end. And that's how it ends. So it passes that trigger in. The only thing that's you have to sort of get is that you want it to be this target is audio parameter controller interface. Target is audio parameter controller interface. And you just want to make sure you get the name right. That's the only catch. You want to make sure you get that name right. But it's pretty easy. You just go like, trigger, execute trigger parameter, and you got your function, and it selects the right one. So yeah, pretty easy to pass. Like I said, this is very easy. So this to build took me like less than an hour. And what I want to stress is that this is creating a custom music system that behaves however I want it to behave from scratch. Less than an hour. So, you might think, oh, well, less than an hour still sounds long for implementing music. Yeah, implementing music in an existing music system should be very quick, right? But building a custom music system from nothing and having that be less than an hour is amazing. So that, I think, is an important takeaway that I cannot overstress. This is not merely me implementing music. This is me building a custom system in under an hour. So, yeah, anyway. Hopefully this was useful to folks, and something a little bit different than Dorian's Run, which I have used a lot. Even though it's edited a little bit weird, we got to see cue points in action, which I think is really cool. And what I probably should have done is this log integer. So you can actually see it. This is where the debug value comes in nicely. And then what we'll do is we'll grab our output log and we'll clear it, and then we'll go meta filter, and then we'll just start playing it. There's our cue point. And it'll just keep spitting those cues out every 2 bars. So this is how you would debug it. And that's why the string is useful for debugging purposes. But the ID is what we end up using for like practical purposes. And then I can simulate on end. I don't remember if I hit it before the C or not. I think I did. Nope. So I ended up hitting it just after C. Yeah. So there you go. Hopefully that was interesting, useful information. This print log is super useful for debugging your MetaSounds and getting data out of them. So y'all have a good weekend. Thanks for checking this out.